If he says test, 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 spank him. Okay?
No. All right, in the back, if you can hear me, right, do this. Do this. All right, good. That's good. No, don't do the test thing. Everybody doing all right today? All right, we'll about 5 more minutes. We'll get started. Just want to make sure this works. Right. Anybody do anything fun in Seattle today? Yesterday? Go see something? What'd you do?
I went to the Seahawks game.
Seahawks game. All right, that was good, right? Anybody from Minnesota? Sorry, man. I'm really sorry. You know, they put up a good fight. Has anybody done the underground tour here in Seattle? A few of you? It's really cool. If you've never been to Seattle, originally, right down here by the water was so low that it flooded out in the beginning of the 1900s, in the early part of the 1900s. And they decided that in order to prevent that in the future, they would actually raise the street a story. So all these buildings were down here in downtown Seattle near Pioneer Square and stuff, and they actually raised the street up another story, and the original first story is still underground there. And underneath the sidewalks, you can actually walk down there. So it's a really, really cool tour. If you want to take something one night this week, go down there, just search underground tour, and you'll see it. I got to say hi to Gail. How are you? Gail Shaw, brilliant MVP from South Africa. She came all the way around the world to talk to you guys, so if you get a chance, go see her today or Wednesday or Thursday, something, right, somewhere. All right, wait another minute or so. And Grant, too. Sorry, I didn't mean to ignore Grant. Grant Fritchie.
Everybody does.
I'm sorry. My colleague at Redgate Software, he's talking today, too. So, all right. I don't have anything else funny to say. Sorry. You can go see the Dreamliners being built if anybody wants to take a day off. If you're not doing anything tomorrow. There's a planned tour up north. That's kind of cool. Or you can go to Alan's Precon. If you haven't paid for Alan's Precon, he does a great PowerShell Precon at SMO and how to do everything in SQL Server and core. And I don't know. I stole some scripts from Alan, so we're definitely worth going to see. Yeah. All right. I don't know. What else is happening? What are you guys excited to see this week? Anything good? Is everybody going to the summit? You all here for the summit? A few of you probably local. Who's local here? Just local? Oh, quite a few of you. Oh, cool. Well, thank you for coming. Thanks. Thanks for bringing out the sun, kind of, today. Not tomorrow. My son lives down here. He lives in West Seattle, and so I spent yesterday just touring around the city with him, just wandering around. We actually saw like a little slice of blue sky and the sun for about 2 minutes yesterday afternoon. So, yeah. It was a bug, yeah, no. I think I came here for like 5 or 6 years, and I never saw the sun. I was here for like 2 weeks a year, and I never saw the sun. So it did not endear Seattle to me at all. I love the sun. I live in Colorado. We have sun almost every day. So no, not boring at all. We have hot weather. We have cold weather. We have snow. We get a little tiny bit of rain. Colorado's fantastic. But you all stay here, please. You're doing fine. We don't need any more people in Colorado. All right. I think it's 10 o'clock. All right, it's close enough. If anybody else comes in, they're late. Well, welcome to SQL in the City. Hopefully you guys enjoyed the keynote this morning. Was that good? Did John do a good job? It's interesting stuff. I'm Steve Jones, and I run SQL Server Central, which I started that site a little over a decade ago, and I've been working for the site almost 10 years now full time. And about 5 years ago, Redgate Software bought my site, so now I work for Redgate and work with all these people. Oh, it's TJ Belt from Utah. Everybody say hi to TJ. He's late. He's late.
Who has a better shirt? I wore this for him today. See you, man.
All right, sorry to interrupt. So I work for Redgate, and we do some cool stuff. We make all kinds of utilities. Please, if you're interested or something catches your eye, ask the people downstairs, and I'll talk about it a little bit, but not too much. So today we're talking about database maintenance essentials, and this is kind of a basic talk about the things that you should be doing in all of your instances. There's nothing wowing or amazing here, but this is the core stuff that you really need to do to ensure that your databases run well, that they run smoothly, that they're available for long periods of time, you don't have unexpected downtime or problems. We're going to kind of cover these things here. I'm not going to read the slides for you. I assume you're big boys and girls. You know how to read. If you can't see the slides, we'll send them to you in a week. So bear with me. So let's start with talking about your files, your MDF and your LDF files. Out of curiosity, who here is a DBA? Who's a developer? Who's like an accidental DBA that got just stuck with stuff? Okay. Well, we've all been there. That's how I kind of started my career. I was a network administrator, and I got stuck with the SQL Server database back in 1991 and had to manage it. So the MDF and LDF files, there's this myth that they manage themselves. If any of you have worked with SQL Server 7 back in 1999, back in 2000, early part of 2000, Microsoft had this marketing campaign where they said SQL Server doesn't need a DBA anymore. It's self-tuning. It's reliable. It'll do everything by itself. You don't need to pay a DBA $90,000 a year to run your database. Has anybody found that to be true? Well, it is true. For a large extent, my 12-year-old can install SQL Server. She can click next, next, next with the best of them, get it installed, and it'll run great until it stops running. Over time, the server will degrade. There's all kinds of maintenance things we need to do, and one of those is managing your MDF or LDF files. Probably the number one question we see on SQL Server Central is, why did my disks fill up? Why is my log file 85 gig and just filled up the entire disk? It happens partially because people are not paying attention to their files and are not tracking them. So let's look at kind of an example here. If you make a basic database, those are your developers, you probably do this all the time. You use the defaults, create a basic database. Please don't do that. Please make a database that's sized differently. But over time, you have activity in your database. And what happens is it grows and grows and grows, these little segments. The auto-grow feature will kick in. Stuff will happen. Occasionally, you have big loads. You'll have big things happen. And what you end up with is lots of fragments in your database, lots of little sections of the file. Even though it says one file, on the disk itself, it's actually fragmented into pieces. Any of you back in the 6065 days remember we actually had to keep track of this stuff, because if you didn't know the size of all those files, you couldn't restore a database. These days, that's not a question. But if we do this on disk, we get the same thing where we actually have all those growths just kind of randomly occurring across our disks. Now, if you use solid-state disk, it's not as big a deal because there's not the random write penalty. But on a physical disk, a head has to move just like a record player. Does anybody remember what a record is? I met a guy a few years ago who didn't know what a record was. It made me feel really, really old. But that head has to move back and forth, and this has to physically spin. And so all this fragmentation ruins some of the advantages of SQL Server. We have read-ahead threads that when you try to scan a table or a large amount of data, it tries to go get that ahead of time. It doesn't work as efficiently if it has to jump all over the disk. So what do we do? For our MDF files, or our NDF files, the data files essentially, what we want to do is we want to pre-size our files to a certain length. My recommendation is I want to have 4 to 6 months of space in my file. So that means I have space for all the data I have now, plus all the data that's going to grow in 4 to 6 months, plus some maintenance space. Your MDF and LDF files are not like Word files, they're not like Excel files, not like text files. We don't have the space that we need for just the data. We actually want to have free space in these files. SQL Server itself is SQL Server OS. The internal team over in Redmond, that's what they call it. Essentially, SQL Server runs as its own operating system inside of memory and inside of the disk, where it manages where the files are, it manages what moves inside and outside of the various memory pools. So we want to have free space. We don't want to have our databases sized to be just the size of the data. We want to have extra space in there. When you need space, you want to grow these files. You want to manually do that. You don't depend on autogrow. Of course, you say, Steve, if I want 4 to 6 months worth of space and I'm going to constantly track it and grow it, am I growing it every month? Really, you're not. What you want to do is grow maybe once a quarter or less if you can. And some of this depends on your size of your database. If your database is 100 meg, just put a year's worth of space in there. Just add 400 or 500 meg because 100 meg just doesn't spend much space these days. If it's 400 gig, you might want to be a little more careful how much space you add. But what I would do is I manually monitor space every month to look at how big it is, how much I've been growing, how much free space I have, and then every 2 or 3 or 4 months, I'll actually do a big growth that'll push me out another 6 months or so. And then a little note at the bottom, if you're wildly oversized, you can shrink the databases. But this should be a one-time event. Please don't ever, ever, ever enable auto shrink. Please don't have shrink as part of your maintenance plans. A shrink, there's valid reasons to shrink, there's valid times to shrink, but it should be a rare event that occurs. It should be something you manually choose to do. What I really want, instead of having all those fragments, is just across a year or a couple of years, I want to have just a few discrete chunks, because on the disk, I will tend to have all this stuff then grouped together, have less work for the heads, and all the read ahead, all the efforts of seeking through the disk work a little bit better. What about our LDF files now? These are a little bit different than data files. The log file is actually a record of all the activity on my server. So the size that I need for my log file really depends on my activity. It's not dependent on database size, not dependent on number of users, not dependent on number of queries. It depends on the activity, the insert, update, and delete activity that occurs on my server. I'll show you an example in a minute. How do you pre-size this? What's the size of your log file? Well, if you've never run this database, or you have a new application, especially for developers, it's really take a guess. So when you say 10% of your database, 20% of your database, but there's no way to know if you don't have activity on a system. So it's really important that you are tracking the amount of log space that you need. The amount you need is determined by the frequency of your log backups if you're in full mode. If you're in simple mode, then it's just a peak size that you're ever going to get to, which you can only figure out by running your system. But in terms of backups, the number of backups that you take per day, per period of time, will determine how much log space you need. And I'll give you an estimate here. If you don't have any idea, please take a guess. Don't just leave it at default of 1 meg. Set something that, guess. I don't know. Look at your other systems, other activity you have, and try to take a guess. Ask somebody. There's no good metric there. The last thing I want to know here is that multiple log files don't help performance at all. If any of you have multiple log files, you're not helping yourself at all. SQL Server works by filling up one log file completely. And when it gets done, it goes to the next log file and starts writing there. There's no advantage. There's no spreading of I/O. Nothing happens with multiple log files. The only reason that you should have multiple log files is if your log file is so large it doesn't physically fit in one of the disks that you have, which is possible. There are systems like that. So let's look at an example here. I've got, this is from SQL Server Central. I've actually plotted the log file backups. So we take backups every hour, and we've plotted the sizes across a day. And you can see the activity kind of goes up and down. At night there's not much. It goes up and down in the middle of the day, and then we send a newsletters late at night, and it starts going up. Really what I have here is I have a peak size, which is the amount of log space I need for the day. Because I'll use this much log. Let's go here. I use this much log. I'll take a backup, and then almost all of this space is available to be used again. And then the next hour, I'll use this much log, et cetera, et cetera, et cetera. So when I were to size this, and I would size this the same way as the data files, that I would set a large size, monitor, and then change it if I needed to. But I would set a pad here, and I've changed the scale slightly just so this works. My peak is in this 41, 42 range. I would set something up here to give myself 10 or 15% more to handle growth, some unexpected occurrence, something else. Same thing shrinking here goes on the log files, is that you don't want to shrink them constantly. I know people that will let a log file grow, they'll run a backup, and then they'll shrink it at night because they want that space back, and then the next day it grows, and then they shrink it at night, and they do the same thing over and over and over again. That's kind of the definition of insanity. Nothing is going to change. There's no point in shrinking your log files to get that space back if you're going to use it again the next day. All right, if you need more space, please ask for more space. For these files over time, you got to monitor them. You got to keep track of what's going on. That's the way you're going to prevent issues. You're going to notice ahead of time that you're growing and that you're going to need more hardware, you're going to need more space, something like that. It's important that you monitor on a regular basis. This isn't a daily activity, really. This is probably something you do once a month. I mean, if you've got that free space in your files, they're sized appropriately, you don't need to monitor every day. But once a month, at least, I would look at the size of my files. You should always have autogrow enabled. You never know what's going to happen on your system. Please enable autogrow, but please do not depend on that to manage your files for you. It will work for a time, but you'll forget about it, and eventually somebody's going to call you and say, my disk is completely full, and that's a bad day, because then it's too late to just add space. Use alerting as well. Make sure that you're aware if something unusual happens and things do need to things grow crazy, somebody loads a year's worth of data instead of a month's worth of data or something similar, alerts will help you know that right away and then respond to those activities if there need to be. And then, again, just keep free space in your files. Since Redgate's paying for this, we're feeding you lunch, all this stuff. We make a tool called SQL Monitor. And this tool is designed to watch your systems, do some long-term trending baselining, and then alert you of problems. And we have a few things in SQL Monitor that are worth looking at that I kind of want to show you. Oops. 2, 3, usually third time's a charm. This is monitor.redgate.com. This is actually live. This is real data from SQL Server Central. So this is my very intuitive cluster name here, and these really obvious server names and my instance names. I have really creative IT guys. Actually, we host at Rackspace, so we don't have a choice on the host names, but this was not me. I didn't do this. These are my SQL instances. We take the live data off SQL Server Central. We have SQL Monitor running on the server. It's hooked up to let the IT guys at Redgate know when we have problems. They get alerts and things. And then we replicate this data over to another server strictly for demo purposes. So you guys can go to this site. This is actually live right now. And the processor time over here is actually the live processor time on SQL Server Central. If I go look at one of my particular nodes here, you'll see I've got alerts there. We leave a lot of these alerts up just so that you can see. But I track on here, SQL Monitor will track my disk space. So for all my drives, I have the space used there, various metrics, performance counters, those kinds of things, which is kind of nice. You can go look at this once a month and see. But really, what you want is alerts. And we pre-populate all these alerts here. These are all based on Grant's knowledge, my knowledge. Brad McGee used to work for us, customer feedback, various things over the years. We've come up with all these default alerts that are set up. And what they're really designed to do is transfer knowledge and make the tool very easy for you to use. So if you set this up, these are already configured. You don't have to try to figure out what you need to do. And one of the things we have in here is disk space. Yes, sir?
Check the boxes and turn them on. They're on by default?
Yeah, they're on. The check the boxes to work with it, if you want to do it. So here's the disk space alert. And you notice I have a low or high value here. By default, we set it here at these numbers. If if you have a terabyte database, you probably don't want an alert at 400 meg. You probably want a little larger. You probably want to change this to gig or something else. But these are pre-configured and they're available. The other thing we have is we actually, and I'm going to go over to my VM here if it wakes up, we have custom alerts. Let me pull up my own. I can't change the demo version, so I'm going to do it here instead. Here's my own system here. It's on my laptop. It's running. This doesn't install anything on your actual SQL server. It all works remote. WMI, T-SQL queries, RPC calls, nothing installed, but in this case, since I have just one machine. We have custom metrics available. In this case, you can take any query that you have, I'm not going to do all this stuff, and stick it in here, and I've got a query here. If I run this, it actually just calculates the free space on my system. If I stick this query in here, and again, obviously you want to test things, I can point this query to all databases, particular ones, whatever I want to do. For something like this where I'm tracking database size, I wouldn't check this constantly. As a matter of fact, I would probably only check once a day because I don't expect my database size to vary dramatically. If it varies a few meg or something a day, I don't really care. What I care about is the trending over time because I'm managing the space in my files. And in this case, I would actually use what's called a calculated rate of change. So instead of tracking the size of the database every hour, what I would do is I would track the change, or every day. I would track the change across days because what I really want to know is my database growing? Any of you have databases where you have less data every month? It gets smaller and smaller and smaller. Not usually. That's a bad sign. It means you might need a new job soon. For most of us, what I would do is I would care about the rate of change here. And of course, I don't want to have to check this every day because I'm a lazy DBA. I don't want to have to go and look at things. I want to know when things go wrong. So we give you the ability to create alerts. And I could easily just create an alert that said something like database size growth. Whoops, we don't want to do that. And I can say, is it more than whatever metric I use? This is calculated, I think, in terms of bytes. So, maybe if I want to say, if I have more than this growth, please let me know that something unusual happened yesterday, and I need to go figure out why I have this big growth in my database. I'm not going to enable this because I don't want this alert to actually occur on my system. But we have all these custom metrics, and then I know John mentioned it. We have this site, SQL Monitor metrics, as well, where people upload their own metrics. They can rate them, discuss them. You can download them, whatever. Grant's written a bunch of these as well. TJ wrote one too, didn't you? TJ wrote one. Don't use his, though. I haven't tested his. Be careful. I'm kidding. But there's all these metrics in various areas, and if you pick any of them, let's just pick one so we can see storage. This was that database file size that I had. There's some information about what it is, and then it actually will explain to you how to do all the setup for different things. So if you have any query that you want to check, we can do that. It doesn't have to be server help, though. You could actually have queries in here for your business. Inventory goes too low, usually large sale. Somebody sells something for an unusual price that doesn't necessarily make sense. You could put any alert you wanted into this system and have it let you know that there's a problem going on. Any questions? Everybody awake? Everybody bored? You may need coffee. All right. You guys are really quiet. I'm just wondering. So most of you have database. You have more and more space all the time. It grows bigger and bigger. And the SAN guys love you, right? They're always happy to give you more space. Whose boss is happy to sign POs for more disks every month? Anybody? Never happens. It's always a problem. We make a product called Storage Compress as well. And what this product does is essentially is designed to compress your data, but transparently to SQL Server. So anybody use row and data compression in SQL Server? A few of you. So that works fine. It works great. It's a little bit of administrative overhead because you have to compress every table, every index separately. It works fine. There's nothing wrong with it. This is completely transparent, though. With this, it actually works as a filter driver in the I/O stack between SQL Server and the disk. And SQL Server sees your 1 terabyte database is 1 terabyte. But on disk, it may only be 300 meg or 200 meg. This compression number here is an average that we have from customers. We have some large banks with terabyte databases running this. And that's the average that we get across many customers. Essentially what it does is it compresses everything down. Very similar to row and table compression, zip compression. There's only a few compression algorithms that actually work well, but it does it all transparently for you. The other thing we do is if you have encryption needs, we can do encryption. But we do it differently than row and data compression. So if you have TDE involved, it does the encryption, and then it tries to compress things. This does it the other way. We actually will do the compression first and then encrypt the compressed bits. So you still get compression value. If you want to see this, I'm not going to demo it because it's kind of boring, essentially. It's just there. But somebody downstairs can talk to you about it if you're interested. All right, any questions? Everybody all right? Yes, sir.
Overhead on that.
Overhead on compression?
Yeah.
So the overhead on compression varies by your workload, obviously, and it varies by the type of data that you have because things compress differently. But it's typically been 5–7%, fairly low. Okay. If you have less than 5% overhead on your system, you probably got problems already. So yes, sir.
So the data that we have in a couple of tables is primarily kind of office docs that we put into the database. So what kind of compression and what kind of overhead are we talking about?
The overhead, again, would be around 5%, 5–7%.
I think you get 73%.
On Office documents? How much compression you get on Office documents? It's so hard to tell because it really varies depending on the content of those Office documents. For example, if you have images inside of them, depending on the image format, like JPEGs don't compress very well. You zip a JPEG, you don't get a lot of compression. But if you zip a bitmap, you get more. So it depends on really your data that's involved there. Hard to say. Test it. I don't have a good answer for you. You can download a demo and test it and see what you would get. That 73% is an average. There's people. If I do AdventureWorks, I think I get right around 50% compression. And AdventureWorks has some Word documents and things inside it if you have the 2008 version with FileStream. So it's hard to tell. It could be 50%, it could be 90%. You'd have to test it. Somebody else? Yes, sir.
Is it the same compression as SQL Backup? Or if it is, does that save some of the CPU load?
Is it the same compression as SQL Backup? I don't know. My guess is it is, but I don't know. This came out of the hyperback side of things, which those were the guys that originally wrote Lightspeed. And there's really only a few compression algorithms that are in use. So
I just wonder if the backup would be faster if this was already compressed with this.
that's a good question. I don't think so. Well, it should be because the I/O would be less.
But is it the CPU load is from the compression again, so fast, if you can just read the compressed version versus compressing it all over again, then I figure it would save.
I think it would have to read it and decompress it and recompress it back down because it's at this is at a filter level. So as you pulled it through the VDI interface and said, give me a page for this database, it would decompress it. So you'd have CPU load, you have less I/O, and you'd have less I/O going back, but I think you would have a decompress and recompress on the backup. Okay? Ask somebody else there. The smart guys are downstairs. Yes?
A lot of your comments are dealing with production databases.
Yes.
The problem I've got is managing a test environment where disk space is really hard to come by. So we always have to try and keep the databases small and the file size small. Do you have any words of wisdom about that?
So you're asking about, you have a test environment and you want to control space in your test environments. This would work great in test. Sorry. This would work great in test. It's a good place in development as well because you could compress those databases and you would have less space. If your test databases, you might be more CPU bound because they're maybe not as big as the production level databases. So it might slow down your testing slightly in that case, but it still should be better because you'd have much less I/O taking place.
Yeah, not specifically on the SQL compress tool, but your general recommendation.
Oh, for managing files? All that stuff applies to the test systems. Now, in the test systems, you typically would not have the growth that you would have in production because you would run a test load, which you might experience some growth in, but then you would shut down your test, right? You may then restore again from production. So you may not have to keep as much free space in a test environment, but I still wouldn't depend on autogrow in a test environment. I would still have some free space in there because you're not necessarily then getting a good test either. If something has to autogrow, you may slow down the test cycle while it's taking place, and you may have not a true test of what the workload would look like in production. I'd still be careful. I wouldn't have 6 months worth of free space in test, right? I might have, 2 test cycles worth of free space, whatever that means to you. Okay. Yes.
Is there any difference between the perf loss from a read versus a write perspective? Is it mostly the write that's slowed down, or is it also slowing down both of them?
Is there a perf loss from the read or write? I'm not sure what you mean in terms of compression.
Yeah.
So the performance hit on compression, and this goes for any type of compression really, is that you use extra CPU to do the decompression and recompression. Okay, so if I read, I have to decompress something to actually use that data, and if I write, I have to compress it before I go back to disk, right? The benefit is, though, that your CPU time is typically much less than the time it takes to put that on disk, because disk is an order of magnitude slower than memory. All right? So either way, read or write, you have a CPU overhead, but it's usually lost in the savings from a disk I/O. Does that make sense? Yeah. Okay. Anybody else? No? You just don't want to ask me questions, right? You like just move on?
No.
It's fine.
The read is going to be cached, right, after it's decompressed.
Yes. So logical reads, this doesn't do anything with logical reads, right? This is only physical reads.
So you're going to experience less of the overhead from reads probably. Because if you're reading the same block over and over, right?
If it's in memory, yes. If you're reading the same thing from memory, there's not going to be the overhead in reads.
Yeah.
But
Correct.
this is not compressed in memory.
Right. This is like it was decompressed when you pulled it off the disk.
Yeah.
And
As long as it stays in RAM, you don't have that continuous overhead of reads.
you live in SQL Server.
Well, you hope. Depends. I mean, some of us don't have a lot of RAM in our servers, so we hit the disks a lot. If you're a lucky guy. All right. Yes.
Just totally unrelated.
That's fine. We don't. None of these guys care. Just talk to me.
And I think you changes over, will it pre-allocate space for you?
No, I don't think so. Ask them downstairs. I don't think data compare actually pre-allocate does anything with space. It would just SQL Server will respond. Data compare just does inserts or updates or deletes or whatever. So that's separate. Yes, sir.
I'm doing a bunch of sharding and SQL Express of all things, and I got a problem with my system tables taking up a large.
Talk to Gail. Gail will help you. She's $400 an hour. Just call her.
Does SQL storage compress system tables or just the?
No, well, it compresses everything, but it's just on disk. It just compresses stuff on disk. So.
Then there's no cheaper free versions that come with SQL Express or not, are there?
No, but you can negotiate. If you want to buy any of these tools for Reggae, I don't sell anything. They don't let me do that stuff. But we have no commissioned salespeople, so they're really good about just working with you. So call them and say, I need 12 or 8 or 500 or whatever. Give me a price. Negotiate. I mean, negotiate really, seriously. So.
Maybe you touched on this at the beginning.
Were you late too?
No.
Oh, okay.
There's a magic checkbox in the enterprise version of 2008 R2 that says compress. Now, did you touch on that and say you can do compression this way, or you can buy the Reggae product?
That's the data and row compression.
Yeah.
I see. Okay. So
It's not a magic checkbox, just so you know.
it's magic if you don't understand.
Well, it appears to be magic, but that's row and data compression native to SQL Server. And I don't think we use the same algorithm. I couldn't tell you, honestly. I don't know what the algorithm being used on our side is. And the row and data one is just, it's weird. But in the row and data compression native SQL Server, and you can use it if you have Enterprise Edition, but you have to compress every table and index on its own and manage that slightly. It's not a lot of overhead. I mean, ask Alan. If you want to know more, Alan does it all the time. All right, let me move on. I'll run out of time here. Let's talk about indexes. Who has indexes? All right, good. Indexes are good. You should always have indexes. Now, indexes, though, are something you have to manage over time as well. You can't set indexes and forget about them. Unlike the network guys that get to set firewall rules and then drink coffee and sleep all day, we actually have to pay attention to this stuff. The indexes that you use or that you set up, and you should always set up indexes, especially developers when you start, please set up indexes, primary keys, foreign keys at least. Those indexes will or will not be used by the optimizer depending on your query, depending on the data volume. So you may have no need for an index on a very small table at first, but as your data volume grows, you may find that you could dramatically increase performance if you added indexes. Conversely, you might find indexes that were being used and you reach some tipping point, they're not being used because there's some other choice made by the optimizer for your queries. The other thing at the time, we changed the way that we look at data. Our businesses may come up with new requirements. They may do new analysis. We may add new tables. So our queries may change over time, and we may need new indexes to support different queries. So again, this isn't something you do every day. It's not something you need to worry about on a micro level, but once a month or so, you ought to think about analyzing your index usage and try to figure out if you have a good use that's meeting the needs of your workload. Well, I kind of talked about this. So let's talk about a few different things here. Missing indexes. Anybody have missing indexes? Why do you have missing indexes? If you know you have missing indexes, go at them. Come on. Jeez. All right. We don't always know we have missing indexes. If you run the query plans, if you do the actual execution plan, and the optimizer thinks you're missing an index, it'll put a little yellow bar in the management studio and tell you that potentially there's an index here that will help you. But the best way is really to look at your real workload, analyze it, and then figure out what index is at. Anybody want to do that manually? Nobody wants to do that. That would really suck. Gail would do that. There's like anybody with a black shirt would probably do it. That's why I don't wear a black shirt. I wouldn't do that. The best way to do is actually use a database tuning advisor. Take your real workload. Make a trace of your real workload, and then use that in the database tuning advisor. It'll chug through all those queries. It'll look at your indexes and your tables, and it'll come up with recommendations. Please don't use Profiler. Use a trace. Now, Profiler is great for defining your trace. And let me just show you so some of you know. There's a tuning template in Profiler. 1, 2, 3. Knock, knock. If I run Profiler here, you don't ever want to run Profiler on your production systems, please. It's really bad. It's a lot of overhead with Profiler. That's not where you want to be. But you do want to, sorry, I forget what version I'm working with here. The database tuning advisor is right there too in the performance tools. When I run Profiler, I can create a new trace. Now this will implement a trace in the back end, but there's a lot of overhead from the actual tool here. When I do this, oops, and I connect them with the server, there's actually these templates. And I've got a tuning template right here. And this is the one I recommend that you use. Do this, start it, stop it immediately, and then you can save this definition off to run a trace, a server-side trace, gather that data for hours, days. It depends on what you're trying to do, but you want a representative sample of what a workload actually means for your system. And then submit that to the DTA. You can stick it on another workstation or something. It'll chug through it and come up with all these recommendations. And then as DBAs or as developers, you have to look at those recommendations and make some decisions about which ones make sense. Right? You have to look at the data being queried. You'll have tables that you should understand. These are order tables, and people always query for multiple orders or single orders or groups or something, and then add certain indexes. You don't necessarily want to add every index that comes out of that recommendation because indexes cause overhead in your system. Every time you do an insert, an update, or delete, not only is the data changed, but the index that's associated with that data has changed as well. So there's overhead involved. You don't want a ton of indexes. How many do you want in your system? It depends. All right. If you have a really heavy OLTP system, busy tables, you want less indexes, 5, 6, 7, 8 maybe. If you're more in data warehousing space where it's a lot of read data and not so many updates, you may have more. You may have 15 indexes or more on tables, depending on your needs. There is a DMV here, DMDB missing index details. That is used by the optimizer. Every time it thinks an index could help a query, it sticks a row in there. Please do not add all the indexes that are in this DMV. Right? There's a lot of data in there. But only a lot of data if you've been running for a while, because this DMV can be reset when you restart SQL Server. So if you're more advanced, if you've had some experience, you might use this to check your recommendations, see if there's something that makes sense, but be really careful. Be really careful using it. All right. Anybody have unused indexes? Oh, man. Why? No excuses. Delete them. No, please don't delete them. You may have unused indexes. Why? Well, your indexing needs may change. Queries may change. Something may happen that you've got indexes that were originally created and they're not being used anymore. When I worked at JD Edwards, we got this cool little CRM type package and from a third party. It ran on SQL Server. So we installed it. And the developers, in their infinite wisdom, had decided that if they created an index on every column of every table as a separate index, things would run really fast. And they did for a while, for about a year, and then they stopped running very fast. And fortunately, we were able to convince them that they didn't need to index every column on every table, especially columns that were never queried, really. You may find that, hopefully, all of you developers out there, please don't do that. Please don't create indexes on every column. Only create indexes on the columns that the optimizer will use to actually limit the amount of data coming back. So things in joins, things in where clauses, but not all of them. Use some judgment here. To find these, there's this DMV, DB index stats usage. Please don't delete the indexes that are in that DMV. Those are the ones that are being used. You can join that back to your list of indexes and find ones that aren't being used ever. Again, this DMV will be cleared out when SQL is restarted. So you want to take the data out of there and perhaps save it over time and look. You'll get a list of indexes that are being used across a month or 6 months or something. And then you can compare that to the indexes that exist on your system and delete the ones that aren't being used. If you do find indexes in there, please don't delete them right away. I would really recommend you disable them first. Make sure you've gone through a business cycle, which for many of us is probably a year. And you make sure these indexes aren't actually being used, because if you get to the end of year closeout, end of fiscal year, maybe different for some of you, and your phone starts ringing because all of a sudden the CFO's reports don't run, you may realize you may need to re-enable some of these indexes. I've had that happen. If you've gone through a business cycle, you're sure they're not being used, then go ahead and delete them. Yes, sir?
How do you get the developers to agree that to work with the indexes you identify that are missing, or unused, or duplicates, or whatever?
How do I get the developers to work with the indexes that the index changes that I want to make? Well, Do you restore their systems at all? Do you send them copies of production? Then their indexes are there, right? I mean, they shouldn't have to worry about the indexing at that point in time if you've got production level systems. If you're trying to convince them which indexes to use, then what I would say is, first of all, be nice. Go buy them lunch. Go do a brown bag session at lunch. I mean, you'd be surprised, just being nice, how often that works with people. I know, a strange concept in this country, but if you are nice to people, they actually respond. But show them with real data. Don't argue with them. Please don't, call them names. Don't say that they're wrong. Say, let's look at this query with your indexes and this query with my indexes. Let's see the difference. And let's see if we're actually saving reads. Am I saving writes? Am I saving time? And just, developers are usually very, very smart individuals, and they'll respond to, a rational argument or a rational reason for doing something, not an argument. Right? Nobody likes to be argued with. Does that make sense? To be nice. Honestly, DBAs, we have a bad reputation as it is. Please be nice. Grant's not here. Grant's a scary DBA, so he's bad. Duplicate indexes. You may have duplicate indexes. It just happens. Developer 1 creates it. Developer 2 doesn't realize it's there. Somebody may say, I want an index on column 1, column 2, and somebody may say, I want an index on column 1, column 2, and column 3, thinking that they're just different indexes, and they're not.
Or the execute create index from missing index DMVs.
Or you create the indexes from missing index DMVs, and it creates lots of duplicates. There's any number of reasons. There's a few blogs. You'll get this deck. Essentially, same thing. You could just go ahead. I would just say you could delete these. If you're conservative, maybe you disable them and let them live for a while. But for the most part, they're duplicates. If they're really duplicates, you may get rid of them. But any of these queries will help you figure out which ones are out there.
One time you need to be very careful about duplicates. When you've got index hints floating around.
When you've got what?
Index hints floating around.
Oh, so that's a fair point. The duplicate index, if anybody uses index hints, please don't use index hints. If you're in a session, don't use index hints, all right? This is basics. Don't use. But that could be a problem, because if there's a query looking for a particular index and you've whacked it, that could break things as well. SQL Search is free from Redgate. Actually, it's a free tool. It'll find all that crap. So you could use that.
In Sprox or in a profiler trace, or where is it looking for?
In the query. In the query, you can do it. And you can do select star from, and you can do an index hint where you actually say use this index.
All my other developers use index hints.
Yeah.
And we can't use them. It's an old mainframe.
It's an old mainframe thing. Just delete them. When it goes to production, just delete them. Just delete all the index hints. The other way it works really well with developers, just don't tell them what you're doing, just do it. Guarantee you, they'll never argue with you.
There's actually a trace flag which turns off index hints server-wide.
So Gail says there's a trace flag will turn off index hints on your server instance. I don't like trace flags. They always make me nervous. But
A startup flag or
Trace flag.
it's a trace flag, DBCC trace flag. So you can do that. All right, fragmentation. Fragmentation hurts performance. All right? It's that simple. Over time, we allocate pages in SQL Server. You add data, we allocate more pages, et cetera, et cetera, et cetera. You may delete things. Eventually, over time, what you have is things get moved around. And the same problem we have on disk, we could have internally inside SQL Server, where the head has to jump around, where it's trying to find data, going back and forth, and it just slows performance down. So what do you want to do? Well, there's essentially 3 ways, or 2 ways, depending on how you read this, for reducing fragmentation, removing the fragmentation in your indexes. It's online and offline, rebuild and reorganize. Doesn't really matter. There's no better way to do it. There's different trade-offs with these 2 types of defragmentation. Online and offline, obviously, there's a performance hit, but there's just trade-offs in the way these work. You have to decide which one works best for your environment, and let's show you how this works. So for rebuild, imagine I have this lovely index, and in essence, I'm moving all around trying to get this data back. And this could be thousands of pages or something. In rebuild, well, of course, if I got other data in the middle. Rebuild, what happens is I actually create a second copy of the index. So if this is 100 gig, this is 100 gig as well. I've created a copy here. And then I get rid of the old index. And that's a very quick switch. It's all one transaction. It takes time, takes resources, and it takes space. Right? But I get a really nice defragmented index. So there's good and bad with that one. Not a lot of locking, because it's creating a separate copy here. So this is in this index. is being used while this is being built. And it's a very quick switch. All right. Reorganize a little differently. Now, reorganize, essentially what I do is I have this sliding window that rolls through my index. And it's looking at the amount of data on every page, based on your fill factor and changes over time. You've got different amounts of data on every page. So this looks at it, and it slides along. When it thinks it has enough space, it'll actually move the data over and try to compact this. Compact is maybe a bad word, but it moves it around a little bit. And so eventually time I can free up space. Then what it does is it takes a single extra page, and it starts to use this page to defrag my index over time. What happens is each one of these moves is a transaction, separate. So if I stop this in the middle, I still have some amount of work being done. If I stop the other one in the middle, I don't have any work being done, right? This only uses a single extra page, so it's not going to necessarily be as clean as the other way to defragment things. Which one do you choose? Well, it just kind of depends on your situation. You have to do some testing, see what the load is, see how much space it requires, see how much time you have, that kind of stuff. There are recommendations here from books online about when you worry about defragmentation. These are from Paul Randall, who worked on the Microsoft storage team at SQL Server. And he has a blog post here where he says he essentially made these up. He's got a lot of experience, worked with a lot of customers. They're not just blind numbers that he threw darts at the wall, but they may or may not be appropriate for you. So if you have no better reasoning or no better idea of what to use, you can use these numbers. If not, if you feel free to change them over time. If you're going through and looking at how long it takes you to defragment things or the workload in your system, you may decide that, I'm not going to worry unless it's less than 10,000 or it's more than 10,000 pages, that kind of thing. I tend to recommend that you prefer rebuilding over reorganizing, if at all possible, but that may be a maintenance window for you because there's going to be load on your system while it's making that second copy of the index. I've got different thresholds here. Brad McGee actually came up with these, so I've got these if you want to use them. We do have some scripts here as well that will help you to manage this yourself. They're intelligent scripts that will look at the index and it doesn't defrag every index all the time. It kind of makes decisions based on the size of the index and the fragmentation level. There's some great scripts here that you can use. We also help you to track this in SQL Monitor in the same way. 1, 2, knock, knock, knock. Penny, anybody? Anybody? In SQL Monitor, we again have an alert set up that they're pre-built so that it will help you to figure out if you've got problems for index. And if I go through here, if I just installed this, this will actually tell me for my fragment indexes. And this alert is only one set by default, but you could change that. You could set something up. Again, this isn't something that you worry about on a day-to-day basis. Maybe every month, once a month you have a maintenance day where you kind of examine how your maintenance is occurring. You may run reindexes every day or once a week or something else, but have some automated process in place, but you may want to just examine it a little closer once a month. We also make a little tool here called Index Manager in Redgate. And there's nothing magic about this. This is actually an interesting tool that came out of, 4 times a year, we actually shut down the company for a week, and anybody can work on anything they want to. And somebody actually decided they wanted to build a little indexing tool, which was kind of cool. And I've already run this against AdventureWorks in this case. You can see I've got an index there. All the rest of the indexes are here. And it recommends here that, it's slightly fragmented here. Let's reorganize this index. It doesn't do anything major. If I were to actually pick this and say, let's fix this, all it does is it gives me a script. And if you look through this script, it just does, an alter index reorganize. We can say alter index over there and reorganizes here. If you were going to use something like this, and you could have your own tools or something else that might do this, please, let's go back. All right, we'll get there eventually. Please don't click this button over here. This is like the OK button in the GUI of Management Studio. You shouldn't click this button. I've got a script here. I should take this script, at least a portion of it, and eventually this will work. And I should put it here in Management Studio. And then you see this button up here below query, this little one you guys are probably familiar with right here. Click that button and save this. And after you've done that, and you give it a name that says it's November 5th, we're doing reindexing, then you can click execute and run it. You know why? Because you're going to do something like this and you're going to screw something up. Trust me. I've been a DBA for 2 decades. You're going to screw something up at some point. And you're going to want to know what you just screwed up. And if you use the GUI in Management Studio, you use the GUI in RTool or somewhere else, you're not necessarily going to know what you just screwed up. It's much better to run these scripts in Management Studio. After you've saved them, keep a log and a record of what's going on. Can't tell you how many times in my career that's actually saved me because I've had documentation of what stupid thing I just did or somebody else told me to do. The alternative is you click around in Management Studio, you click a server setting or a database setting or something else, and then you go run something and you don't realize that you made 4 changes, but you only remember 3 of them. Or worse, somebody asks you tomorrow why something doesn't work, and you go, I didn't change anything, right? Because you forgot that right before you were going to lunch, you ran something like this yesterday. All right, please don't just click OK. Use the GUI all you want. At the top of almost every dialog, there's a little script button that you can use. And let me just show you one to make some change. So if I were to come in here and just change some option here, let's go in here. You know, let's say I made this a contained database. There's this little script button at the top that will allow me to save the change that's being done. Then I can execute the script. I learn how the T-SQL works, and then I have a record of what I just screwed up. Because trust me, you guys are going to screw up. Not often. I know you're smart, not often. But once in a while, you will. So please keep a record of what you're doing. All right. I'm going to run late here, I think. It's all right. You don't want to see anything else. All right, statistics. Real easy. If you don't know what statistics are, please read about it a little bit. We've got great articles on SQL Server Central. There's documentation books online. Essentially, this is a graph, a histogram of the skew of your data. So if we were to imagine that we have a table that lists the phone numbers and names, like the white pages of everybody in the U.S. Do you guys know what the white pages are? A few of you. Anybody use the white pages anymore? All right, a few of you. So in the white pages, the Joneses are well represented. I think we win overall. I think we win. There's more of us than any of the rest of you, so you lose. The Fritchies, there's only 2 of them. You know, we don't really like those guys. But if you were to query the data for the Joneses or the Fritchies separately, you may have a different query plan because the amount of data comes back differently. Statistics allow the optimizer to look at the skew of your data and try to determine what the best way is to get the data back. Short answer. Okay? If your statistics are out of date or not working, you may get incorrect query plans. You may have parameter sniffing issues. You just may have issues. So for statistics, if you use Reorganize, you got to separately update these statistics. It's real simple. If you use Rebuild, it will update the statistics in the index columns, but if you have other statistics on other columns, it won't do it. All right? It makes sense. Read the slide later. We'll just keep going. All right, corruption. You can't prevent corruption. If you have corruption in your system, it's not anything you did. It's not anything you forgot to do. All right? It's almost always some type of physical hardware or software failure, a driver problem, a bug, physical degeneration of your disks, your heads, your memory circuits are getting old, something else, bad power, right? Seattle, you guys have the lightning and storms here. You may have power issues. So you can't prevent it, but what you can do is detect it as soon as possible. Because the last thing you want is for you to come in Monday morning and somebody says, I got this lovely 824 error in this query, and it's a corruption error, and you realize that all the orders from yesterday are gone because of this corruption. And then you realize that really it's all the orders from last week because for the last week, all my backups have corruption as well. When SQL Server does a backup, grabs all the 1s and 0s off the disk, it throws them in the 1s and 0s into another file. Doesn't really care if the engine can read the 1s and 0s off that disk. Doesn't care if they can interpret them to actually meaningful data. It just duplicates whatever's there. So if there's corruption in a disk in your MDF file, corruption goes in the backup. And you restore the backup, you get your corruption back. It works really, really well. All right? However, when your boss comes around and says, why are we restoring backups from 2 weeks ago, that's not so good. All right? You guys need a really good backup or a really good resume. Whichever one you want, I don't care, but you better have one of them. All right? Ideally, what you want to do is check corruption with DBCC CheckDB every day on every database. Does anybody run it on every day on every database? A few of you. It's hard if you have databases of any scale or size, or if you have a lot of instances, because it's resource intensive, it takes time. The best way you could probably do this is to run it on another system, do a restore somewhere else. That way I test my restore, and then I have DBCC running to look for corruption. Now, ideally, I should do this every day. If you can't do it every day, please, at least once a month, get this run on every database you have. If nothing else, if you've only got one extra server and you can restore all 50 databases over there, do 10 of them on Monday, and 10 of them on Tuesday, and 10 of them on Wednesday. But get this done once a week or once a month if you can't do it every day. Can you fix it? Well, there's a limited fixing ability in DBCC. Hopefully Gail will agree with me when I would say, please don't do that. Please don't run that. Because if you use it, there's the repair allow data loss and the repair not allow data loss. But the allow data loss one, they mean data loss, seriously. It does not care about your data. It only cares about making things link back up correctly. So if it drops all of yesterday's orders, it's totally fine with that. All right? Your boss is probably not happy with that. So please, 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 if you're not sure, if you have any doubt, if you're concerned at all, please just call Microsoft if you have corruption. They'll help you work through it, try to get all your data back, help you figure it out. In non-clustered indexes, if that's where the corruption is, you can drop and rebuild them. Again, if you're not sure, please call Microsoft. But the corruption is not necessarily gone then, right? It's gone out of that index, but the fundamental problem you have with the corruption, which is maybe your disk or your HBA cards or the firmware or something else, is still there. So you really need to examine your whole I/O system and all your hardware when you've got corruption and figure out where the problem is. All right? Of course, be prepared to restore from backup if you have corruption. Now, SQL Monitor, we have an alert. I showed you alerts before. We've got these backup days that are just tell you how many days are gone. So if backups aren't running for some reason, it just sends you an alert. And then we have page verification. We check to make sure that you've got that set on your databases. You should have that set on every database. Oh, we're not done. We're close, though. There's checksum. Please set that on the database. It's almost no overhead, but please set it. If you've got databases that were upgraded from 2000, you may have torn page detection set. Please change that over to checksum. Get that set. And then really quick, I'll just show you this because I know we're running low on time. In Backup Pro, we actually try to try to make this easy for you. This is SQL Backup Pro. It does compression, encryption, all the cool stuff that you want done. We have this thing in our the latest version we released this year called Scheduled Restore Jobs. So I can pick some database, I'll pick AdventureWorks, and it goes and looks at the backups that I've made. I can have this pointed to my existing server or a different server. I can have it overwrite the database, or what I may want to do for something like this is I'm testing DBCC, I'm looking for corruption. I create a new database, and then I overwrite on subsequent restores, kill connections, all that good stuff. I can fix the file locations, which is kind of cool. But what we'll do here is as part of the restore process, we'll run DBCC CheckDB here. So it'll do the restore, it'll run DBCC CheckDB, and then it'll log it, and I can have it drop my database here at the end on success or on always, depending on what matters for me. But I can use this to automate all my restores from all my databases over to some separate system. And if I've got 500 databases, I can restore 50 on one day, 50 on another day, 50 on another day. You guys get the idea? 50, 50. Nod. Everybody nod? Yeah. Okay. All right. Just want to be sure. And at least every few weeks or every month, I get DBCC CheckDB run, and I make sure that my systems are actually working. All right. Backups. Again, good backup, good resume. Right? Pick one. Make sure you have one. Backups are really important, and make sure that they work well. But you got to make sure they restore, because backups don't matter most of the time. What matters are the restores. When something goes wrong, when you need to get data back, you need a restore that works. So please use a full recovery model, unless you have a reason not to. If you know the reason not to, that's fine. You can run in simple mode or bulk log. But if you don't know better, especially in production, please use full recovery model. Please make full backups and log backups. Full backups do not clear the log. All right, so make sure you have those. I would say always back up with checksum. Not a lot of overhead, but it just can prevent potential errors from occurring. And then I always say back up to separate files. It's the next item on there. There's people that, for ease of scripting, will back up to the same file over and over. They'll use with no init, and they'll put 2 or 3 backups into a single file, and then they can restore from that file. You're dramatically increasing your risk level. Anything happens to that file, anybody deletes it, your system administrator corrupts it, something happens, you lose all the backups in that file. That's a really bad day if you've got all your full backups in there. Okay? Use separate files every day. Most of the tools, our tool, other tools, will timestamp them with the date and time the backup's made, that kind of thing. And then please test the restores of your backups. You don't have to do it every day. That's ideal. But again, just like checking for corruption, check your restores. Make sure once a month or so you've restored every database so that you're sure there's nothing wrong with your backup process. As a consultant, I've been called into any number of companies where we find out that all the backups they thought they were running to a particular tape device or to a particular server weren't working. There was some problem, and then they can't restore anything. It's a bad conversation to have. Please make sure you store your backups somewhere off-site, at least a few of them. I know these days a lot of people are trying to get away from tape and things, but you never know when you're going to have a problem at your facility or some problem, some natural disaster. We had a little tiny storm in New York last week. I don't know if any of you guys heard of it. Is anybody from New York, New Jersey? You are? My condolences. Sorry. But it happens. It could happen here. You've got all this stuff out here. If that stuff ends up over here, that's bad. Right? So you want to make sure you back up somewhere else. I've had fires. I've had environmental issues in facilities where we were not physically allowed to go back into the rooms where the tapes were. So it's good to store stuff off-site. We do compression. We do alerts. You guys get it. All right, last thing, maintenance jobs. You should have maintenance running. Some of the stuff we talked about today, you may have other maintenance for business purposes that runs. Please set it up and automate it. If you're like me, you probably don't want to sit there and click execute every night to make sure your backups run. We have a great scheduler in SQL Server called SQL Agent. Please use it to schedule things. Try to keep your maintenance, though, very simple. There's maintenance plans or there's maintenance scripts that are available. Try not to vary that for every single instance and every single database. You will have exceptions, and you may have groups of servers that work in different ways, but try to just have a couple of maintenance plans set up so that when something goes wrong, you're trying to debug it, and you're in a hurry, you understand what's being done and what isn't working on the servers. If you have a lot of instances you're trying to manage, there's a great event manager. Actually, it's called Event Manager from SQL Sentry that will schedule jobs and things across multiple instances and help you manage things. It's a fantastic tool if you can use that. And obviously, you schedule things at times when you're less busy. Some of you have 24/7 shops. Some of you aren't. If you're 24/7, it's complicated. It's hard. There's no magic solution. You have to find time to do this maintenance. Okay? If you postpone it, you're just asking for trouble down the road. And then lastly, monitor your jobs, of course. Use SQL Monitor or something else. But don't over-maintain. Don't do maintenance that isn't required. You don't need to rebuild every index every day on every table. Right? You just don't. It's just a waste of resources. Don't do more than you have to. You don't need to update statistics everywhere. Don't update statistics after you've done a rebuild of the index because you're duplicating work. Right? Please don't ever enable auto shrink, ever. If you remember nothing else, okay, check DB every day on every database, if possible, or as often as possible, and don't ever auto shrink. But also, don't use shrink in your maintenance plans. It just doesn't make any sense. All right? If it's going to grow back up in between those maintenance windows, there's no point in shrinking it back down because you've got to have that space available that you're going to use again anyway. Please don't do that. We have alerts and that kind of thing. I've said a lot of this already. Okay, this is not stuff you got to do every day, though. This is really once a month or so. You should examine, make sure that your maintenance is appropriate, that it's running as you expect it, you're watching your file sizes, that you're not forgetting anything. You have statistics and that kind of thing. The challenge is really to take kind of this checklist of things, and again, you'll get these slides in this recording, and go back next week and look at your instances, your production level instances. See that you're actually performing this type of maintenance on there, that you're actually tracking your file sizes and things. And if you're not, set those jobs up, and they really do make your life a lot easier because you want to keep track of this stuff, but you don't have to worry about it every day. Automate as much as possible, and good luck. Lastly, I'll take questions here. We're about done. I know people are trying to get in. We have great forums, SQL Server Central, where tons of people answer questions. Gail's there answering corruption questions all the time. I usually just say call Microsoft if you have questions, but feel free to ask. And I'll have these slides up on my blog there, and they'll also be emailed to you. Again, thank you for coming. Hopefully you guys enjoyed today. Please let us know what you like and don't like about the event, and hopefully we'll do it again next year. All right? Thank you. I'll do questions up here if you want. I got to